Hello students, welcome to the class Mathematics. In the last class of the chapter Mathematical Reasoning, we discussed some of the problems. Now in this class also, let us discuss some more problems. Here, let us see this question: which one of the following Boolean expressions is a tautology? Here, four options are given. We have to verify which option is a tautology. So here we can see a new term, that is a Boolean expression. Boolean expression is a logical statement which is either true or false. And a tautology, of course, already we have discussed the term tautology. It's a statement which is always true. So here now we have to decide which statement is a tautology. So for that, let us check one after the other. First, let us take the first option, P or Q or P or negation Q. So here let us write this statement as P or Q or negation Q. By the distributive property, here we can see P or is common in both the compound statements. So by the distributive property, we can write this statement as P or Q or negation Q is equivalent to P or Q or negation Q is always true statement, because the disjunction of a statement and its negation is always true statement. That's why Q or negation Q is equivalent to T. So this statement is equivalent to P or T. Now we have to find out the statement which is equivalent to P or T. That's why let us use the truth table for this. For that, let us take two columns headed with P and T. P is a statement which is either true or false, but T is a statement which is always true. So in both the cases, this statement is T. Now let us find out the truth value of P or T. But we know that the disjunction of two statements is false only when both the statements are false. Here, can you see the case in which both the statements are false? No. That's why in all the cases P or T is T. Now if you observe the truth values of the statement T and the truth values of the statement P or T, we can say that they have the same truth values in all the logically possibilities. So we can say that P or T is equivalent to T. That's why the statement P or T is equivalent to T. So the compound statement is equivalent to T, which means it is always true. So it's a tautology. That's why first option is the correct option. And in the same way, we can check whether these statements are tautologies or not. Let us see. Let us take the second option, P and Q or P and negation Q, which is equivalent to P and Q or negation Q by the distributive law, which is equivalent to P and Q or negation Q. Of course, already we have discussed P or negation Q is always true. That's why we can denote this equivalent statement by T. Now it is P and T. Let us find P, T, P and T. So P means either true or false. T is always true. And this is the conjunction of the statements P and T. Conjunction of two statements is true only when both the statements are true. That's why here in this case both the statements are true. That's why P and T is T. But both the statements are not true. That's why in this case P and T is false. Now if you observe the statements P and T, they have the same truth values. That's why we can say that P and T is equivalent to P. So P and T is equivalent to P. So the statement P may be true or may be false. That's why it can't be the tautology. Let us take the third one, that is C, that is P or Q and P or negation Q. Here also by the distributive law we can write it as P or Q and negation Q. But we know that P and negation Q is always false because simple example, it is a marker and not a marker. Is it true? It is absolutely wrong statement. That's why Q and negation Q is always false. So here also let us see P or F. Statement P, statement F. P is either true or false, but F is a statement which is always false. Now we are finding P or F. Condition for disjunction is when both are false, disjunction is false. That's why it is false, and in this case it is true. Now once observe these two, they have the same truth values. That's why P or F is equivalent to P. Here also this statement is either true or false. That's why it can't be a tautology. Next, option D. P and Q and negation P or negation Q is equivalent to P and Q, and we can write this negation common, that is negation of P and Q. Now once you observe this one, it is the statement P and Q and not the statement P and Q. Is it possible? It means can you say that it is a marker and not a marker? Can you say no? So it is always false. That's why it is also not a tautology. So like this we can say that it is the correct option. Option A is the correct option for this question. Students, the next one is the contrapositive of the statement. If you are born in India, then you are a citizen of India is. Here, for the given compound statement, we have to write the contrapositive. But what is the given statement, given compound statement? The given compound statement is a conditional statement because this compound statement uses the connective if then. That's why it's a conditional statement. Now let us see the different forms of a conditional. If the given conditional is P implies Q, then it's converse. Converse means we have to interchange hypothesis P and conclusion Q. It means a Q will be hypothesis and the hypothesis P will be conclusion. If you interchange hypothesis and conclusion, you will get the form of the conditional which is called converse. Next, inverse of the conditional. Inverse means if you give negations to both hypothesis and conclusion, then you will get negation P implies negation Q. This form is called inverse of the conditional. And if you take the converse of the inverse, you will get contrapositive. Contrapositive, which is converse of the inverse. So, what is the converse of this inverse? Negation Q implies negation P. Now, we have to write the contrapositive for the given conditional. So, what changes we can observe? Hypothesis P will become conclusion with negation, and conclusion becomes hypothesis with negation. So, with the help of this form, we can write the contrapositive. So, what is that? If the hypothesis will become conclusion with negation and conclusion will become hypothesis with negation. So, what is the conclusion? You are a citizen of India. So, first you have to write this conclusion with negation. That's why if you are not a citizen, if you are not a citizen of India, then we have to write this hypothesis as conclusion with negation. Then you are not born. You are not born in India. This form is called the contrapositive of the given conditional. That is, if you are not a citizen of India, then you are not born in India. This is the contrapositive. Now, students, let us see this question. The Boolean expression P and Q, or P or negation Q, and negation P and negation Q is equivalent to. So, for this, as the given compound statement is very lengthy expression, it is better for us to depend on the truth table of this compound statement. With the help of the truth table of this compound statement, we can easily find out its equivalent statement. So for that, first we have to identify the different statements. So there are mainly two different statements, that is P and Q. For that, let us take two columns headed with P and Q. So, for any two different statements, there are four possibilities, that is, both are true, true and false, false and true, both are false. After taking the different statements, you have to see if any negations are there. Yes, for both the statements P and Q, there are the negations. That's why let us take two more columns headed with negation P and Q. So, with the help of the truth values of P and Q, we can write the truth values of negation P and negation Q also. That is false false, false true, true false, true true. After that, let us take compound statements which are given in brackets. The first one is P and Q. The next one P or negation Q, and the next one negation P and negation Q. Now it is very clear that it is the conjunction of P and Q. For the conjunction, the truth value is true only when both the statements are true. So only in the first case P and Q is true, and in the remaining three cases P and Q is false. Next, we have to find the disjunction of P and negation Q. P and negation Q. Disjunction. Disjunction means when both the statements are false, result is false. So search for F and F. It is not F and F. Not F and F. Yes, it is F and F. Again it is not. So only third one is F and F. That's why it is false. And in the remaining three cases are true only. And the next one, negation P and negation Q. So for negation P and negation Q, we have to find out conjunction. But the conjunction is true only when both the statements are true. And in the remaining all the cases, it is false. That's why let us search for true and true case. Not true and true. Not true and true. Not true and true. Yes, it is a true and true case. That's why in this case only negation P and negation Q is true. And in the remaining all the cases it is false. So we have got the truth values of these statements. Now let us find out the truth value of this statement. Let us denote it by R. Okay, instead of writing this lengthy compound statement, let us denote this statement by R. So what is R? It is the disjunction of P and Q, P or negation Q. P and Q. P and Q means this one. P or negation Q means this one. For these two statements, we have to find out disjunction. So disjunction means when both are false, result is false. Let us search for false and false. Not false and false. Not false and false. It is false and false. So result is false. And in the remaining cases, it is true. Next, let us find the truth value of this statement. Of course, already we have got it. Now, for these two statements, let us find AND. Here, let us denote this statement by yes. So, now we have to find R and S. R and S is the final compound statement. So R and S. S means this one. For these two statements we have to find conjunction. Condition for conjunction, when both the statements are true, result is true. And in the remaining three cases, compound statement is false. That's why search for true and true case. Not true and true. Not true and true. Not true and true. And this is true and true. That's why this case R and S is true. And in the remaining cases, it is false. Now, we have to see. You observe the truth values of these two. What is that? Negation P and negation Q and given statement R and S. If you observe, the truth values of these two statements are equal. So, from this truth table, we can say that these two statements are equivalent. That's why for the given statement, compound statement, negation P and negation Q is the equivalent statement. That's why option D is correct option. Let us see the next one. The negation of the statement, if I become a teacher, then I will open a school, is the given compound statement is a conditional. For that conditional, we have to write the negation. But we know that negation of the conditional statement P implies Q is equivalent to P and negation Q. Okay. With the help of this result, we can easily write the negation of the given conditional statement. So here, if you observe the changes in this negation, here we can see that the first statement P remains the same. This implies becomes and the negation is given to the second statement Q. Here also, to get the negation of the given statement, let us make the same changes. So for this, we have to write the first statement as it is. So, what is the first statement? I become a teacher. I become a teacher. So, what happens next? This implies becomes and. So, I become a teacher and next, for the second statement, negation should be given. So, what is the second statement? I will open a school. What is the negation of this statement? I will not open a school. That's why I become a teacher and I will not open a school. I will not open a school. So, this can be the negation of the given conditional. Students, now let us see this one. The truth value of the compound statement P and negation Q and negation P and Q is. First, let us take the given compound statement, that is P and negation Q and negation P and Q. If you observe this compound statement, the different statements are connected with the connective and. But we know that the conjunction of the statements is commutative. That's why we can write this statement as P and negation P, here these two in one bracket, and negation Q and Q, these two in another bracket. And if you observe, it is the conjunction of a statement and its negation. The conjunction of a statement and its negation is always false statement. And here also the conjunction of a statement and its negation. That's why negation Q and Q is also false statement. And also it is very clear that false and false is also false. That's why we can say that the truth value of this compound statement is false. And we know that the statement which is always false is called contradiction. So we can say that the given statement, compound statement, is a contradiction.